Throughout these videos, we have been using the PCRS visualizer to show you how various C statements change variables in memory. You have seen how each function call has its own name table and space on the stack. You've also seen that there's an area of memory called the heap. In this module, we will review some of those concepts and add a few new ideas about the layout of memory. When we are programming, we like to imagine memory as a single, vast array that houses all of our data. This array is the programmer's view, a logical view of memory. This memory array is divided into segments. Each segment stores one particular type of data. In this video, we'll explore the code and stack segments. Let's say we want to write a program in C. Here we have a main function that, at some point, calls the function sum, which takes 2 arguments and returns an integer. We also have a single global integer variable z that has some value. This code, once it is compiled into machine instructions, is stored near the top of our array in the code segment. Though the array starts at 0, the code segment would be very close to, but not at 0. As this code executes, it will call the functions main and sum. Each function invocation is allocated space in the stack to store local variables. This stack space functions similarly to the stack data structure, in that the most recent function call is at the top of the stack, and that function calls are removed in last in, first out order. Let's focus on the call to the sum function. We will need to store all the local variables and arguments of the sum function somehow. So we will allocate a stack frame, which is enough memory on the stack to store these variables. The stack frame is located on the top of the stack, above the stack frame for its caller, the function main. Once sum is finished executing, it no longer needs its stack memory. We will pop the sum stack frame from the stack and return a value to our caller, main. By popping off the sum stack frame, we free the resources assigned to it, so they could be used by another function call. Furthermore, main's stack frame is now at the top of the stack where it should be. The top frame in the stack is always for the function that is currently being executed. This stack behavior implements the rules for variable scope that we have become accustomed to. Local variables are only accessible while the function that defines them is active. Once the stack space has been deallocated, the variable is no longer a valid memory location. In the next video, we will learn about the rest of the memory array.